Welcome everyone to today's Europlanet webinar. We have with us Michel Blanc, our well-known planetary science colleague, and of course one of the originators of Europlanet project itself. Michel specializes in space plasma physics. He is currently emeritus professor working at IRAP in Toulouse, and IRAP is the Astrophysics and Planetary Science Institute in Toulouse, France. His research focuses on everything magnetosphere, ionosphere, thermal sphere of the Earth and of the giant planets, most in particular, and also comparative studies between planetary systems. He was the interdisciplinary scientist on the Cassini mission, and of course has been involved with JUICE. Actually, he's at the origin of JUICE in a way, and he's involved with Juno and other missions, and certainly mention those. Michel is also a member of the Air and Space Academy, the International Academy of Astronautics, and the Academia Europaea, and he chairs the panel on exploration on COSPAR. So I've known Michel for many years. I'm happy to have him here, but I recently learned that he has been collaborating quite frequently with colleagues in China on the Chinese aspect of the Chinese space exploration program. And since we in Europe are not always aware of what's going on with the Chinese space exploration program, I thought it would be interesting to learn more about that, and hence I invited Michel. So without further ado, Michel, the floor is yours.
Thank you very much, Martin. Thank you, Callan, for the very nice invitation. Of course, it's a pleasure for me to address the audience of Europlanet, which is really dear to me. So, as Martin said, I think I've been visiting China for quite some years. I actually started in 2016 when I was appointed as executive director of EC Beijing, which is the sister institute of EC in Bern. Which was established at the time on the headquarters of the National Space Science Center in Beijing. And since then, I've been visiting China regularly as a visiting professor at NSSC and other positions, and having a special look at the Chinese space program. I must say that over the years, even just over 10 years, the evolution and progress and development speed of this program is really very impressive. And I think it is important for the European community to at least know what's happening and to be able to study what are the interesting partnerships offered by our Chinese colleagues. So I will go through a summary of the Chinese exploration program with a focus on planetary, so the moon and planets. But of course, what they are doing in China is broader than that. But it will give you a taste of Chinese space science, I hope, in more general ways. So let me first say that I want to thank a few colleagues from whom I took some information. First of all, Mr. Mathieu Grialou, who is the Space Council of the Ambassador of France in China. Mr. Grialou is doing a fantastic job, in fact, of following the program development in China in space. He's publishing a bulletin every month about Chinese space science and Chinese space events. And if you are interested, you could just write to him to ask to receive this bulletin, which is really a treasure of information about China in space. The second one is Professor Wang Wei from the Lunar Exploration and Space Engineering Center, who actually provided some slides, in particular about lunar exploration, that I will show. Professor Wang was actually at the EPSC, at the EGU recently in Vienna, organizing a full session about the results of the Chinese space program. The third one is Professor Pierre-Yves Mélin in my laboratory, IRAP. So Pierre-Yves is the PI of the Dawn instrument on Chang'e 6, which is actually the first Sino-French planetary science instrument that landed on the moon. It landed actually on the far side of the moon, as I will explain, last year, about exactly last year. Then finally, Dr. Bertrand Cordier, if you want to have a view of a broader scope of Chinese space science, China is also very active in astrophysics. And there is right now in space the SVOG mission, which is a joint Sino-French mission studying gamma ray and X-ray emissions in the universe, which is receiving fantastic results. If I have time, I'll touch on it, but more generally, Bertrand is a good person to really know what's happening in terms of collaboration and big collaboration with our Chinese colleagues. So I also wanted to say that you may know that with the team, we published 3 years ago this book, Planetary Exploration Horizon 2061, which was an attempt to make an overview of the possible developments of planetary exploration during the next 40 years. And we actually worked with our Chinese colleagues on the Chinese translation. So if you want to learn the vocabulary of planetary science, I recommend this book, of course, in Chinese, of course. With that, this is to say that we have close links with our Chinese colleagues. So let me maybe put the basis of the scene. China is going to space. And China is now today the second space power in the world, behind the US, of course. And this is an adventure which has started actually some time ago. So I wanted to give you key figures about what is the Chinese space program. So China, we have to realize, started its adventure in space a little bit after the other big spacefaring nations. It was the 5th country to launch a satellite, DFH-1. It was on April 24 of 1970 on the Long March 1, which was the first model of a rocket. Well, you know, it was a difficult time. It was the beginning of the Cultural Revolution, but still, China landed this satellite at this time. And of course, there have been many others since then. In 2024, China is the second nation by the number of launches, with 62 launches over the year, and I suspect it will be more this year. The estimated budget, about 11.9 US dollars in 2022. That's the earliest source I have. So again, number 2 after the US. Nearly 600 satellites in operation, again, number 2. And the way they are developing the program, well, it's a 5-year plan system. So every 5 years, China is announcing a program and the budget, the operations in these 5-year plans, which means that most of the time we don't have really a vision of the development of the program longer than 5 years. But on the other hand, one can see from the achievements that more or less the 5-year plans are really implemented very accurately and safely. So once you have the plan, it is executed and successfully most of the time. And I think that's a very important asset of the Chinese approach. Right now, so the space sector in China represents over 200,000 public employees, not to speak of the private sector. I will come back to that, which is developing very quickly. So you have the curve, the number of launches. You can imagine that it's really close to an exponential very clearly. So now we are over 60, or we were over 60 in around 20, and it's increasing. And in addition, you see that the number of rockets that can launch payload into space is increasing. It's diversifying. We'll come to that later. And also, it is not only the institutional players. Well, there are more and more institutional players, including the universities. But in addition, there is a spectacular growth of the private sector in China. Of course, in a Chinese way, but it's a private sector. And that's very important, which means that China is also a key player of what we call new space. And we have to be aware of that. So here, for instance, again, you have the number of launches. I think the curve goes to 2022, but so in red you have China. Here in gray you have the US. So you see that the USA without SpaceX would be a smaller number of launches, but with SpaceX it's still more. So which means that the space sector, in particular in the US, of course, it becomes really important in the way that the USA is leading the development in space. But China is sort of following because its private sector is also developing. To give you an idea, and those slides come from Mr. Rialou, this was the industrial ecosystem in China in space until 2020. Essentially, two big national companies, CASC and COSIC, which were realizing all the hardware elements and flight elements of the Chinese space program. So that was till 2010. And now, from 2015, you have the logos of all the players of the space program in China. You see it's a total explosion. Not only there are more public players, but also more and more small private companies which take their chance in space. So it's really a vibrant program. Now, they have, of course, a very important and versatile launch infrastructure. So you have here the different launch sites which are available in China at different latitudes. So there is one in Xinjiang here, Yuchan. Some of the astrophysics missions are launched from there. Xinjiang also, east of Tibet. Taiwan in the north, not far from Beijing, in fact. And the one we know best because it's the place where planetary missions and lunar missions are launched is Wenchang here. Wenchang is a site at 20 degrees latitude on the island of Hainan, which is really the southern tip of China. So this Wenchang launch site is developing very quickly. And in addition, now they have two launch sites in the sea. So Haiyang near Qingdao, and Yanjiang, which is not far from Hong Kong. Hong Kong is here. So with that, you see that they can really increase access to space, of course, and they can launch more and more spacecraft into space. To give you an idea of this explosion of the program, the Wenchang spaceport, which is the place where they launch all the missions to the moon and planets, now has a commercial sector which is developing. So this is the plan they have. They want to open a series of launch pads for commercial operations, as you can see. Around that, the idea, I mean, the Chinese, is to develop really a private ecosystem for space activities in connection with the development of a touristic hub. I mean, China, the space is very attractive for Chinese people. It attracts a lot of interest. So it will or should become a very important tourist hub where people would come, be exposed to space, and sort of participate to the space adventure, which in today's China is becoming something like very important. So institutional launchers, you see that it was the Launch Mars series. They are actually diversifying all the launchers. Basically, Long March 5 and 5B, they are the rockets which launch the vehicles that go to the moon and to planets. And they are working on developing heavy launchers because they will need it to send humans to the moon. So it's the next step that is in development here. Once they have these new rockets, they will be ready to start a human spaceflight program that can reach out to the moon. In parallel to that, there are lots of commercial launchers. I won't go into detail, but just to give you an idea, you see there are many. They can launch small payloads into orbit with a very diverse possibility of offers made to the commercial customers. So all that is in full explosion, and with that, of course, China can expect and actually is accessing to space. So what I will do in the remainder of this talk is tell you about access to first the Earth orbit, then to the moon, and then we will finish with the Chinese program for exploration of the solar system. So first step, of course, going into orbit with humans. So it's human spaceflight. Well, you know that China, since 2022, so now 3 years, has been putting into space and in operation its own space station, which is called the CSS, the Chinese Space Station. It can host 3 astronauts simultaneously. You can see here a relay operation with 3 new astronauts arriving. They are very happy to arrive. And 3 others are ready to go back. So they are very happy to go back, of course. So this station has been managed and operated by China itself without any international support since 3 years. It works very well. And of course, it's a fantastic place to train people to go farther into the solar system. So this is the result of something which was a very systematic approach to human spaceflight, what they call a 3-step strategy. The first step was to launch manned spaceship to master human space technology with vehicles basically like the Soyuz. It's the example, and then they learn to do EVAs and so on. Then they launched a space laboratory to understand how to do experiments in space in microgravity and in EVA and so on, and develop R&D experiments in orbit. And the third step was to construct and operate China's space station. So we are now at this third step, and we have a sort of permanent human space infrastructure of China in space, which I think is looking for opportunities to open to international partners. Well, with that, China, of course, is really ready to go further. You see that with the diversity of components that they have in the station, they can, of course, receive the cargo and crew from Earth. They have several elements where they can do scientific experiments in space, and they really operate all the time in a permanent way. So with that, of course, they are in Earth orbit. And the next step, naturally, and it corresponds to a long lunar dream of China, which is the legend of the goddess of the moon, Chang'e, is to go to the moon and first to do science on the moon and maybe later to science humans. So I wanted to pay tribute on this photo to Professor He Huayu. Huayu is a very nice colleague. She's the co-principal investigator of the Dawn instrument on Chang'e 6, which is an instrument that landed on the moon just a year ago to analyze the emanations of radon from the lunar regoliths. She is also very much interested in sample analysis. She's a geochemist, and in her laboratory in Beijing, which is the Institute of Geology and Geophysics of the Chinese Academy of Sciences, she's receiving the samples from the lunar surface. Now there are 2 series from Chang'e 5 on the near side, and now from Chang'e 6 from the far side, doing cosmochemical analysis of the samples to understand the history of the moon. So I think she's a fantastic scientist. By the way, we had a lot of pleasure working with her, and she's heavily involved in the present and future of lunar exploration. You see her with the return capsule of Chang'e 5, which was the first sample return mission, full sample return mission operated by China to the moon and back. With that, well, let me tell you a little bit about how the Chinese lunar exploration program has been developing. And after that, I will show you a video. I hope it works. Again, our Chinese colleagues are proceeding in a very systematic way. I like to say one step after another. And the principle is it's well planned. And they have a series of steps. And they accomplish each step until it is successful in terms of mastery of the technology. And once it's done, they can go to the next step. So the lunar exploration program is exactly an example of that. The steps were systematic. So you see that orbiting started in 2007 with Chang'e 1, and then Chang'e 2, and then landing. So the first landing, automated landing, was Chang'e 3. It was in 2013. In 2014, Chang'e 5 test experiment. So it consisted in testing the return capsule from the moon before doing the mission itself. It was totally successful. Then landing and roving. So that was Chang'e 4. Chang'e 4 landed on the moon and delivered a small rover, which is called U2-1, to explore the moon surface with mobile capacities for the first time. Then Chang'e 5 was the first sample return from the near site, totally successful. And just last year, Chang'e 6, which was a sample return from the far side of the moon. So you can imagine much more difficult because there is a problem with the relaying of data and of telecommunication. So maybe I will show this short video, which gives, I think, a good summary of how this program developed. Do you hear the sound?
We don't have sound, Michel. If you stop sharing for a moment, and then when you go into share, there will be a share sound tick box. If you just make sure that is selected, then
so I will open my mic, maybe. Do you hear it?
No, I'm afraid not. I think the easiest way probably is to pause.
Okay.
Start sharing again. Make sure that tick box.
I can comment the images. This is just a short summary of course, the moon itself, what it is, and so on. And we move quickly to the summary of the program itself. So this shows the first lunar mission, 2007, Chang'e 1. With the launch, going around the moon and impacting. And then there is the first photos of the surface. Chang'e 2 in 2010. So they prepared the landing site for 23. And they went to the landing point and did a close flyby of asteroid Toulouse. And the world first 7-meter resolution full moon map of the surface. Chang'e 3 for the first successful landing. Of course, it's an animation, but you see the small rover U2, which actually did a traverse of the moon rather short. It has technical problems after I think a few hundred meters, but it was the first time. So this is real images showing the first lunar rover made by our Chinese colleagues. And then the photo of the lander taken from the U2 rover. So then this one is the test of the sample return for the sample return capsule. But again, fully successful with atmospheric re-entry. And after that, we see that the capsules are recovered in Mongolia systematically. China was ready for the first scale sample return, so that was Chang'e 5, which landed on the near side and did a sample production. And you see here how the system returns the samples to Earth. It's a rather complex system. You go back into orbit. I mean, it's a sort of Apollo strategy. You make a rendezvous in lunar orbit, you transfer the sample to the capsule, and you send back the capsule to Earth for recovery. So needless to say, it was totally successful, and the samples have been recovered and actually have been recently distributed to a series of scientific teams, including, I think, 4 or 5 international teams, and one in France by a group, and 1 or 2, and 2 in the US. So this is Chang'e 4. Chang'e 4 was the first ever landing on the far side of the moon. It took a special transmission system to send back the data to Earth via a relay satellite that was put into operation before. And there were several European instruments on board from the Netherlands and from, well, it is African Southern area. You remember Bob Wimmer-Scheinhuber, who was the leader for one of the experiments. So I think with that, maybe we can stop. So the idea is this program has been very successful. You have here for the case of the Chang'e 4 mission a summary. So the lander, a rover, the relay satellite, which was needed because the rover was on the far side of the moon, and the relay satellite was launched a few months before the mission itself. And you see, at this time, there were collaborations with several European countries, including Germany, the lunar neutron measurement. So that was Bob Wimmer that we saw before, and also a Swedish experiment. And I think there was also a radio experiment here from the Netherlands, which was the first test, actually, of doing radio science from the moon. Let's say partly successful. The Chang'e 5 mission.
Michel, could you go back to your microphone?
Sorry?
Could you go back to your microphone? You switch the microphone to the sound is a little bit worse. If you go back to your other microphone would be better.
Okay, do you hear me now?
Yes, very good. Thank you.
Okay. So this shows the radar experiment on U2, which is the rover of the Chang'e 4 mission. So it was the first radar study of the subsurface of the lunar bedrock on the far side, of course, of particular interest. Of even more interest, of course, is the sample analysis from Chang'e 6, which was next mission. So Chang'e 5 was the first Chinese sample return mission. As we said before, it's been totally successful, and the samples have been distributed to international teams, many teams in China and in Europe and the US, and are now under analysis. You have a view of the capsule recovery. It was in December 2020 in the Mongolian desert. You see here the return capsule with one of the people in charge, and here the recovery team with the special equipment to be able to operate in these difficult areas. So Chang'e 6, sorry if it's in French, because of course we do a little bit of cocorico here, since actually one of the instruments was French, and actually it was the first instrument delivered by CNES and by several French laboratories to Chinese planetary mission. Dawn, and Dawn was part of this fantastic adventure. Dawn operated for about 48 hours on the surface of the moon, doing analysis of the emanations of radon at the surface of the regolith. So very quickly, this is the summary of this mission, Dawn, and well, the two PIs, as I said, are Pierre-Yves Mélin of IRAP and He Huaiyu of IGG in Beijing. Of course, it was it was a long story to develop this collaboration. I won't go into the detail, but of course, this kind of thing happened at the highest level. So there was a formal agreement between the two presidents to fly this mission, and it was developed in a rather complicated context because most of the development took place during the COVID times, so difficult, but in the end very successful. So the objective of Dawn is to measure the emissions of alpha particles from the regolith here, which are sort of the end product of the interaction of the lunar regolith with the solar wind, with all galactic and solar cosmic rays interacting with the surface and inducing nuclear reactions. So here with Dawn, it was the design was made so that we can provide constraints on emissions of radon and polonium to better understand the chemical cycle of the evolution of the regolith. So the results are still under analysis, of course. So you have the view of how Dawn was looking at the surface. It had actually two series of sensors, one looking just down the lander and one looking partly to the sky for comparison. And you have the happy team of Dawn here. So it was, of course, during the operations at the surface of the moon. You probably recognize some of the colleagues. Of course, the PI, the project is Pierre-Yves Mélin. He's here. In the Operations Center of the NAOC, National Astronomical Observatory of China in Beijing. And many other people who probably know, Sylvestre Maurice here, Patrick Pinet, one of major lunar specialists in our lab, and so on. So a very happy adventure, and I would say we are ready to do it again in other opportunities. But for some political reasons I will explain, opportunities for the moon are not nearby. But I will show you what are the next plans after Chang'e. So Chang'e will continue with Chang'e 7 and 8. They will focus on the polar regions of the moon to look essentially at the resources in terms of water. And from that, they are going to focus on a concept which is the International Lunar Research Station, ILRS. So ILRS will develop mainly from next 2 years. And the idea is to deploy a fully robotic system of scientific platforms to do experiments on the moon that will deliver essentially science. So let me tell you a little bit more. So these slides are from Professor Wang Wei, and they were presented at the last AGU in Vienna. So the concept is to have several countries working together to develop, let's say, a research infrastructure on the moon. Well, you know, Europlanet is a research infrastructure. So this is a research infrastructure on the moon, which is international, with a series of autonomous operation platforms that do scientific experiments in different disciplines, and of course, which have their own energy supply, control system, navigation system. So all the infrastructure you need to operate scientific experiments on the moon. The science is organized in the following way. There are 5 themes for scientific developments on the moon to be conducted by the ILRS, the International Lunar Research Station. So the first one is lunar geology. So basically, as written here, it's focused on the question of finding the origin and the evolution of the moon, understand what happened to the moon, how was it created, how did it differentiate, what is the history of the evolution of its surface, and what are its local resources now, mineral resources and water resources. So I would say that's the core, lunar science or lunar geology. But the second one is lunar astronomy, so lunar-based astronomical observations. So the idea is this time to go rather maybe on the far side of the moon, or the second step, and to look at, in particular, the very low frequency radio waves, where you can go deep into the universe, look at the dark ages, and the dawn of the universe at the time when the first stars assembled and the first galaxies assembled using radio emissions. So astronomy from the moon. The third theme is the space environment observation, so of the Sun, Earth, Moon system. The idea is the moon is not isolated. It is actually part of the Earth-Moon system. And the component of the system where you can best feel this strong connection is the space environment, because if you are sitting on the moon, you spend part of your time in the solar wind and part of your time through the tail of the magnetosphere. So you have a fraction of the two worlds, and in addition, you are exposed to galactic cosmic rays. So the moon is a place where you can, at one place, observe emissions from the sun, emissions from the Earth. By the way, you can also observe some of the ENAs that are emitted by the Earth itself, the structure of the magnetosphere, and of course, all the radiation from the galaxy. So that's the third theme. Fourth theme, developing experiments, scientific experiments on the lunar surface and learning how to do it. So as you write, you see they write lunar ecological and basic scientific experiments. So what they mean by ecology is try to understand how you can develop on the moon closed loop systems where you generate elements that can self-support the presence of astronauts, for instance. So grow things for human and in particular plant development. Learn to do that on the moon, extract materials, and do a lot of experiments that are specifically adapted to the environment of the moon. So, of course, zero pressure, exposition to space, and so on. And finally, the fifth component of the research, it will be a specific research platform, is what they call resource utilization. So we say sometimes ISRU, in situ resource utilization. It is only to learn how to live on the moon in a sustainable way by using the lunar resources. So that means, of course, taking the minerals of the moon to produce oxygen, to produce energy, to produce food, and using the material of the moon to develop the infrastructure of the buildings, of the bases, and using all of that also to, for instance, produce water and so on. So develop a self-sustainable ecosystem based on the resources of the moon itself. So that's the fifth platform on which the IRS is planning to work. So with that, you see the ILRS, it's a complex project for a space project. It is composed of 3 segments. So a lunar surface segment that will be deployed progressively with a series of launches. A lunar orbit segment that will serve as a relay for telecommunication and so on, and also for some experiments in lunar orbit. And the ground segment, of course, that will monitor all that, send commands and retrieve the data. and do the science analysis on Earth. So a very complex project which is going to develop, let's say, over the next decade. Well, so it's an international project. You see here the list of participants as it was presented at the last EGU. International organizations, research institutions, NGOs, and the current list of national participants. So the two founding members of IRAP are China and Russia. In fact, China and Russia will both contribute to the launches. Some of the launches will be Chinese and some of the launches will be Russian. And here is the list of countries which have signed an agreement with the IRAP. So as you can see, there is no European country, of course, because in the current situation, the participation of Russia makes it impossible for Europe to participate. With that, so it gives you a perspective on what's going to be next in lunar exploration. And I will go to the, let's say, further now into the solar system to give a short review of the plan. So this is a snap view of one of the main squares in Qingdao, which is a place I like very much, with this beautiful monument, which is a sort of symbol, of the dynamics of China going into space. So I talked a lot about the Chang'e program. So Chang'e is the goddess of the moon, and the deep space exploration program of China is called Tianwen. I'm sorry, I don't speak Chinese, in fact, but I know what Tianwen means because my Chinese colleague told me. So Tianwen means Tian is the sky, and Wen is questions. So Tianwen means questions about the universe. And the origin of that is a Chinese, an ancient Chinese philosopher, Chu Yuan. So he lived around 240 to 278 BC. So you see, a long time ago. And he wrote a poem where there was a series of questions he was having about the universe. I put only 3 of them. What are the limits of the universe? Where are the stars located with respect to the universe as a whole? What is the relationship between stars and the universe? And of course, he had many more questions. So the fact that the deep space exploration program of China is named Tianwen means that, for us, it resonates like it's a science-driven program. The program is made to address scientific questions, even if it's technology-driven. What is important is to answer scientific questions. So I will go briefly through the different components of the program, which has started, very brilliantly. So Tianwen 1, it was launched in 2020, during the COVID times, by the way. It was the first Chinese Mars mission, and a complex one already, with an orbiter, a lander, and a rover, all 3 successful. 5 tons sent to Mars with this Long March 5. A totally successful mission, as far as I know. As you know, it's very difficult to go to Mars, and it was a success. You see here some views of the arrival of the composite vehicle to Mars before injection of the lander into Mars orbit, and some of the views of Mars during the approach. And of course, what was important is that the landing was successful, which is really, as we know, something quite difficult to achieve. So here we see some of the approach. And so after that, you see the release of the parachute system during the descent. And finally, the images of the landing, which was totally successful. And finally, you can see here how the lander of this Tianwen-1 mission delivered a rover to the surface of Mars. The rover name is Zhurong. And Zhurong did actually a lot of observations at the moon surface. Our lab contributed to one of the experiments, actually the LEAPS experiment, which was on the top of the rover. You see here the rover sending some images of the landing platform. So Zhurong, I think, did very well. It did a traverse at the surface of Mars, you see, in this area, which is relatively flat. And it can be considered as a fully successful mission. So that was, first step was difficult, actually very difficult. But it was, I think everybody was surprised that it was so fully successful. So that means our Chinese colleagues do master the difficult technology of landing at the surface of Mars. Then the instrumentation was quite diverse with camera, of course, navigation camera, multispectral imaging. There was a ground-penetrating radar, the LEAPS, to which our instrument contributed, and a small climate station, also with a microphone. Tianwen-2. So Tianwen-2 is the next step. So after Mars, I visited to a small body of the solar system. Actually, Tianwen-2 was launched last week successfully, and now it's on its way. And this cartoon shows actually the complexity of this mission. So this mission will go from the Earth to its target, the first target, which is a near-Earth asteroid, actually a quasi-satellite of the Earth. There will be a small lander that will go to the surface, take a sample, go back into orbit, do a rendezvous with the orbiter, and go back to Earth. They will do then an Earth flyby, and at this point, they will deliver the sample to the surface of the Earth and continue after a Mars flyby to go in a rendezvous with a comet nucleus and orbit a comet nucleus. So two phases, a near-Earth asteroid and then a main belt comet. So all that is on the way now. Let's see for the results, of course, and we wish our Chinese colleagues the best possible success. So again, a not easy mission. And you can see that each time, in a way, the complexity of the mission is increasing. And our Chinese colleagues are learning from experience to do, let's say, more and more complex things. So Tianwen-3, well, actually one step further into complexity. Our Chinese colleagues want to do a sample return from Mars. So not easy. So again, you have the very complex scenario of the mission, where, you do a full scenario for sending a lander at the surface of Mars, taking the sample, going back into orbit of Mars, and then injecting back into a return trajectory to Earth, and finally deliver the samples to the surface of the Earth. So I must say I'm not a specialist, of course, of this kind of complex technical mission development, but it's a really very daring and challenging mission. It is currently to be launched, I think, 29 on 30. And our Chinese colleagues are really focusing on this mission and really working on making it in the planned schedule. So, if all that is successful, it might very well be that our Chinese colleagues could be the first to return a sample from planet Mars, which of course would be a first. Let's see. Well, Tianwen-4. So Tianwen-4 is the other mission which is currently in preparation. Of course, it is sort of my favorite mission because it's going to Jupiter, as you can imagine, so which is my favorite target with Saturn. So Tianwen-4, actually contrary to what is shown here, will not go to Uranus, let me say immediately. In the latest scenario, there is only one spacecraft, and all of the spacecraft will be injected into Jupiter orbit. The plan is to launch this mission around 2030, with an arrival date about 2036 or something like that, or 37. So that Tianwen-4 would arrive in orbit around Jupiter probably a little bit after the end of the JUICE mission. But there are interesting things to do with that. First, because it may be a very good, solar wind sensor while approaching Jupiter at a time when JUICE and Europa Clipper will be inside the magnetosphere of Jupiter. And the second thing, of course, is that the observations of the Jupiter system by Tianwen-4 will ideally complement observations to be made by JUICE a few years before. And finally, third but not least, Tianwen-4 will focus on a different moon. So from what we know now, even though the announcement has not yet been made officially, I must say, what I've been told is that Tianwen-4 will go in orbit around Jupiter, will do a tour of the Jupiter system, will go in orbit around Callisto in much the same way as JUICE is going into orbit around Ganymede. And cherry on the cake, our Chinese colleagues are studying a small lander to do a landing on Callisto and do the first operations ever at the surface of a Galilean moon. So, of course, that's a very exciting mission. I've been following relatively closely its developments, and I think this mission, like the previous ones, by the way, will be or is open to international collaboration. That's very clear. There will be a call for international contributions as soon as the mission is announced officially. And one point I wanted to make, of course, is that for the study of the Jupiter system, we are really in a fantastic situation. It's really a pleasure to be a Jupiter scientist these days because, we have NASA sending Europa Clipper to Europe and to study its habitability. We have, of course, ESA sending JUICE to Ganymede. Now our Chinese colleagues, CNSA, are sending a mission to Callisto. So the 3 icy moons of Jupiter will be explored in detail by 3 different missions. And in addition, our Japanese colleagues from JAXA are studying an Earth orbiting telescope called Laputa that will be able to monitor the emissions from the Jupiter system, in particular the Io and Europa tori, at the end of the next decade. So that will be a complement to the in situ observations by space missions to have this Earth orbiting telescope, sort of the successor of the Hisaki spacecraft, that will help understand the Jupiter system as a whole. With all that, we have, I think, all the ingredients to propose and lead a fantastic international Jupiter system exploration program that could be proposed, for instance, under the auspices of COSPAR. So,
maybe Michel, we can wrap up. Because
yes, it's my last slide. Thank you. And Tianwen-5, not yet official, but I wanted to say our colleagues are working on a mission that would go to Neptune and Triton. That would complement, again, of course, the plans for Uranus mission on the the western side. So with that, thank you very much, and of course, I'll be very happy to answer questions.
Thank you so much, Michel, for this super exciting overview. I'm all flabbergasted here by all the exciting things that are happening and are going to happen in the future, and that are happening right now, actually. So let's go into some questions. We just take some time for those questions because it's such an interesting topic here. We have one question already in the Q&A from Leo Enright, and Leo writes, I realize this is a highly speculative question, but do you imagine any circumstances in which China might facilitate landing the ExoMars rover on Mars?
Oh,
It is a speculative
oh yes, that's
question,
an
I
interesting
guess.
question. Yes, of course, yes. Well, I cannot speak for my Chinese colleagues.
Obviously.
What I can say is I can feel the atmosphere, current mood in China. I really think China is looking for international partners and for a partnership on ambitious missions. There are lots of political obstacles to that, but I think, I mean, why not? Once Europe if Europe is interested, and ESA in particular, to do this kind of ambitious collaboration with China, I not. I don't think there will be a no from the start on the Chinese side. But of course, I am not speaking on behalf of China.
Obviously, we understand. Yes, so other questions. We can also unmute you if you would like to ask questions by voice. We can unmute you. You just have to. There's another question coming in right now. So let's go there. Michel Lisoni asks, 1, will the data from the Taiwan program be entirely open to the international science community? And 2, what are the obstacles to collaboration between Chinese planetary scientists and European/Western planetary scientists? The two communities don't seem to communicate much. How could we improve?
Yes, okay, thank you. So, for the first part, I think actually the Tianwen-4 mission, which is the one I know best, I know the words for that. In the call for collaborations, China will specify that they're open to all kinds of international collaboration. So that means they would welcome contributions to the design of the mission, to the delivery of instruments, or only to the science. And of course, that goes also through making the data from the missions available internationally when they are delivered. So that's one point on which I think China still has to make progress. I mean, to make their data more freely available. It's partly a question of culture, I would say, but that's the intention. So from what I know and from the wording that will be used, everything is possible. It really depends on the interest of the international partners. So the second question, you ask, what are the obstacles to let's say collaboration? So, well, actually, between you say the European and between the Chinese and international scientists, I think as far as you talk about scientists, there are no specific obstacles, I would say, except the fact that probably we need to communicate more on the interest and opportunities on each side. But I think the main tool is to have a dialogue, scientific dialogue, to use international meetings, or to use European meetings open to Chinese and Chinese meetings open to international partners. I think Europlanet, in fact, could play an important role on that. As far as I know, and I was in April at one interesting meeting among many others happening in China, which was called the ICDSS, International Conference on Deep Space Science. All these meetings are open to international partners. And they are the places where I think maybe European scientists should come more, just to get acquainted with Chinese scientists. I mean, as you know, between scientists, we always find ways to discuss. In Hefei in April, there was a really very vibrant discussion between Chinese and quite a few, actually, French and European participants.
Yeah.
Now, if you speak about collaboration between agencies, of course, it's different because it depends on the political agreements at the highest level. So it's a little bit different. But I think we, as scientists, can help a lot by establishing the normal dialogue between scientists on open science that should prevail in the area of planetary exploration, at least.
Yes, and Andrew Ball is sharing a link to a data archive. So it's in the chat there for everyone to see. And
yes.
Guray is commenting that the Middle East Technical University in Turkey will also send a micro rover to the moon surface with a Chinese mission. So they are clearly open to international collaborations. And I saw on one of your last slides that there was not on the official side. I mean, not on the organizational side, but on the company side, there were some Swiss companies involved. With I think with
yes, of course. Also the private partnerships are a little bit different, even though they remain under control of nationalities, of course.
Yeah.
But yes, I can only confirm that the Chinese program is open to international collaboration. It's written. In France, for instance, there is a regular yearly meeting between CNES and CNSA, usually in November or December, where CNES and CNSA discuss between themselves the prospects for future collaboration, and the wording is very clear. In the case of Tianwen-4, which is a mission to Jupiter, it was written that all levels of collaboration are possible.
That's fantastic. There's another question by Andrew Ball. He asks, do they plan to develop their own RHUs and RTGs for science mission applications? Do you know that?
Well, yes, what I heard, of course, I don't know the details of who is doing it and so on. Since as soon as they have a plan to go to Neptune, as you can see, I asked them the question, how do you go to Neptune? Of course, you don't go to Neptune with solar cells. And they said, yes, so we need to develop RTGs or RHUs, and that's something which is now in the technology development plan. I don't know how long it will take, but there is an intention to do this development.
Yeah, clearly. So Leo Enright has another follow-up question. Is there one specific planetary meeting in China that you would recommend attending?
I think there are several, but the one I was mentioning, the ICDSS International Conference on Deep Space Science is one of them. It's really a very open scientific meeting. I can circulate the agenda of the last one if you are interested. And this one is every second year, but there will be more. There are 2 or 3 series of workshops and international conferences on planetary science specifically, which are planned. So this one, ICDSS. DSCL will also develop a series of workshops. And I know Macau University of Science and Technology is also having a series of workshops more or less every year. So yes, I can send you a list. There are 2 or 3 interesting ones.
It would be great we can maybe post some links, or maybe we can do a little written article within Europlanet newsletter, or it would be really interesting to have those links.
That would be useful,
as well. Yeah. Okay. Are there any other questions among our attendees?
I don't see any. I think we've answered everything.
Yes. I think we're 10 minutes over the hour, but this is such an exciting, interesting topic that is well worth spending a little more time. So I think we will wrap up this session for today. Many thanks, Michel, for your very good overview. Many thanks for everybody who attended. And we will be back in about a couple of weeks' time, actually, 20 days, 3 weeks, with planetary defense. Then there will be a film as well. So stay on the outlook for that. And with that, I thank everybody and see you next time.
Thanks, everybody.
Thank you.
See you in a few weeks.